Replacing ultra hardware. We're not going to talk about replacing storage blades or director blades or any of the older equipment. Most cases, the hardware should not be replaced before we, technical support, have created an RMA for the part. There's usually no opportunity to troubleshoot an issue once the part has been replaced. The issue may have actually been caused by a software issue or a different part. We don't want to replace the wrong one. Even if it is clear which part needs to be replaced, it's usually easier to find the part serial number while the part is still installed in the realm. If an experienced customer needs to replace a part to make the realm accessible and we're not immediately available, go ahead and replace the part. This is rarely the case. Okay. So first we're going to talk about replacing a storage node. An OSD that is a member of a blade set should not be replaced. That there are rare exceptions, but they are rare. Replacing a node can mean either replacing the node chassis or replacing one of the external drives in this context. The realm, why don't we just replace an OSD that's a member of the blade set? If it's online, the realm is either currently using the data on it, or if it's in reconstruction, it may potentially use that data later. We can bring this OSD out of reconstruction if we determine that there was nothing wrong with it. That it just was unlucky or something like that. No critical part of an OSD, such as the drive, should be replaced if the node is a member of the blade set either. So how do we get it out of the blade set if we wanted to replace it? It must be removed by completed OSD drain. We looked at that, or by reconstruction before being removed. An OSD in one of the following states is not a member of the blade set and may be replaced if it's failed, drained, or not activated. Not activated means it's brand new and never was added into the blade set. If the GUI shows an OSD is offline, it may still be a member of the blade set. We saw that in our example, so we're going to click on the node's details pages. We're looking at examples of the ASU 100. But the same concepts apply to the ASU extra large, the AXF 100 storage nodes as well. Okay, so here is an OSD where reconstruction is completed. It is now failed. That means reconstruction is completed. There's no object storage area here. There's no blade set membership. It is not a member of the blade set. It is safe to replace. Okay. This OSD is drained. So that process that we talked about where we're moving the components off gradually completed, that process ends with the system removing the OSD from the blade set and decrementing that spare, just like we saw in reconstruction. So there's no object storage on it. It is not a member of the blade set. It is safe to replace. Let's talk about replacing storage node external drive. A lot of times, if there's a hardware problem, it is with the drive. Okay. Charlie ASU 100 has 6 external drives accessible from the front, 1 external SSD accessible from the back. The internal M2 MV MS SSD may not be replaced by the customer. We may make exceptions at some time in an emergency, but generally we want the whole node back if there's anything wrong inside. Engineering does not want customers opening up the nodes. It never has. We have made exceptions in the past, and we will again. But generally, it's better idea to let our depot doing the opening up and swapping. The Charlie external drive should be replaced after consulting us if it has a solid red status light. That means the controller's decided there's something wrong with it. Now, that doesn't mean it's actually failed. It could mean that it's predicted to fail, but either way, solid red light on a drive means it should be replaced. The drive has a smart predicted failure. The node reports that it is missing. If a drive is missing, we're generally going to reboot the node to see if it just finds the drive, or if the logs of the node indicate that the drive is malfunctioning in some other way. Maybe we see a lot of sense timeouts to the drive or something like that. This actually happened in a node. So I grabbed all these warnings, so this was nice. A nightly test that we do on the OSD's drive said, look, the statistics are kind of getting a little bad on this drive. So we set node 6 to a smart predicted failure on this. Issued warnings, ASU12 itself went into warning state, and we had a node disk is missing from, this is different. The node disk is missing from the node. In this particular one, I pulled the drive. I actually had to run FISC-OSD on the Linux FISC-OSD. You don't want to just grab a hard drive to simulate a failure. That was a mess, but I did reproduce that failure. So here we are. We went into the node detail page for that node, and we looked at the drives, and we see, again, predicted failure. So if this node was still online, we would drain it, because maybe this drive is still pretty good. If the drain started causing slowness, or the node just stopped functioning, then we could either manually start reconstruction. There's a button there to do that, or reconstruction would just start if the OSD stopped responding in a very similar way that we saw in our demonstration. Okay. So let's say that reconstruction has finished or drain has finished, like in one of our examples here. This particular one, 1.2, is failed, so reconstruction is finished. So that's good. We're going to blink the LEDs to help us locate this node in the server room. In this particular case, the drive is indeed solid red. And my camera didn't really capture it. This is fire engine red here. But let's say that it wasn't, we just thought it was a little slow. We could run the pan from PanFS. We can't do it from the GUI to tell the drive to light up the identity light. It would be blinking there for the drive. If the drive was unresponsive, this wouldn't work. But if it was unresponsive, it would probably be red in the first place. And you can do different things to make sure that you know which is drive 6. You could also consult your handy dandy map, but it's nice to be sure. Okay, so as long as the node is not activated, and it's not activated because it's failed, you can hot swap the drives. So we're going to push this maroon button to the side. That's going to release this hammer. We're going to pull it straight out. We do not unscrew the drive from the sled. You're going to get a good drive from us that looks exactly like this. You're going to put it in. You're going to push it in until you feel the click. And this that will close this lever here, and it will be all good. Go. You're going to throw away this drive. We do not want it back or destroy it or whatever. If it was the SSD, here it is in the back. So you're going to install the replacement drive. The whole thing comes in, so you just put it in, and the status light will be red for about 5 seconds when the drive powers up. You're going to watch it to make sure that status light turns itself off when the drive is powered off. Then we're going to go back to the node detail page. We were flashing the node. We don't want to be confused later, so we're going to stop the LEDs. If we had, I believe that the new drive is not going to be lit anyway, but it doesn't hurt just to set the LEDs back to normal if you ran this in the first place. If you don't remember, you can run this anyway. It doesn't hurt anything. Okay. So in the node's detail pages, the node is still going to be failed. It doesn't just go to be not failed. We have to do some other things later, but we do want to make sure that the node recognizes the new drive, and now it says that it is good. So we're all good there. OSD now is an inconsistent internal file system. You remember that the data is, I guess we didn't go over this, but the data, in fact, in the OSD's internal file system is striped across all the drives, and that is now disrupted. So it is not part of the internal mapping. So what we're going to do is the node needs an entirely new file system. At the same time, the president will not allow a node that has been failed or drained back into the blade set until it has a new file system. So for two reasons, we need to reinitialize the node. That is not available in the GUI because it was tempting people to reinitialize nodes that shouldn't be reinitialized. So we have to do that with PanCli. So from our repset director, we're going to go syscontrol node, the name of the node, reinit. For example, syscontrol node ASU1 reinit. Okay. If the command fails or the node is not accessible on the network, we're going to reinitialize it locally. We can SSH into it, or we can use IPMI, the network, or a VGA console. We can go syscontrol node reinit. We're going to be prompted for the hardware serial number, and we can put that in. If that fails, we can use this low-level command. Putting in the hardware serial number just kind of verifies that we are on the correct node. That fails, we can use this low-level command. This doesn't check anything. It's going to reinitialize whatever node you're on. So you want to make sure your console is on the correct node. The pan-unconfig is the low-level command behind reinit, and we're going to tell it to reboot. If this hangs for some reason, and sometimes it does, just power cycle the node with the front button. Because the pan-unconfig almost always succeeds. Sometimes it doesn't transition to the reboot. What happens when you reinitialize the node? It unconfigures itself. That means it resets every local configuration to the factory default. It lays down an entirely new internal file system, the file system that stores PanFS data. It increments its data serial number because its hardware serial number is going to be the same, but logically it is a new node, so it's going to have a different data serial number, and it reboots. The president knows about this reinitialization command, so it removes the node's record from the realm database, but the DHCP record is not removed just yet, so it should get the same IP address that it had before. It rejoins the realm as a new node in a known enclosure. We didn't go over that, but new nodes in known enclosures, you do not have to unlock the realm. President knows that nodes in the enclosure are to be added to blade set 1, so the node comes online if it is healthy. If the node was previously configured with an IPMI address, it retains the IPMI configuration because reinitializing the node takes no action on the BMC chip. And that's where the IPMI address lives. Okay. Failed drive does not need to be returned to Panasas. Please fill out a certificate of destruction for the drive, and so we can get a warranty back from the manufacturer. That's it. This is pretty simple, really. Let's just real quick here check on reconstruction. storage. Okay, so home says 17 hours. That sounds about right. With the millions of little files in there, that sounds about right. Data, about 1 hour and 28 minutes. And we still don't have an ETA on projects. This looks pretty good. Okay. So let's go back to our replacing hardware. The Charlie or Echo storage node has a hardware in any part other than an external drive or a network cable. We replace the entire node chassis. By the way, if there's any kind of network flakiness and we suspect the cables, we don't have to prove it. We just send you a new cable. Panasas RMA policies do not support replacing any part inside the node's chassis except in an emergency. And an emergency could mean any number of things. Exceptions will be considered an emergency in which a blade set has volumes whose failures exceed redundancy, and replacing internal storage node part may allow these volumes to be successfully reconstructed faster. All right, we want to replace the whole node. Let's say this node is slow. There's no explanation for it, and we think there's something wrong with the NIC. Or we think that there has been some kind of warning about the NVDIMM or anything like that. We want to replace the node. If the node is responsive, blink the node LEDs if needed. This is the same blink. Now, if the node is not responsive, this is not going to work. If you're not sure, you probably will be able to identify the node. If you need to, you can flash some other nodes around it. That can be a little tricky because you got to make sure that whoever's in the server node knows that the nodes that are healthy are the ones blinking, not the ones that needs to be replaced. Anyway, here we go. We're at the node to be replaced. We're going to power down the node with the front power button. We're going to remove every one of the external drives and carefully lay them in a safe place, not where they're going to have static electricity. We're going to remove the network cables, make sure they're labeled so we can reconnect them to the exact same interfaces later. We're going to pull the node out the front. We're going to push this release lever down, and then we're going to pull straight out with this lever and this floppy plastic pull handle. These are very, very tight. So if this is kind of stuck, you might want to go around the back and give it a little push. That sometimes helps. Once we get it out, we're going to install the replacement storage node, assuming that it's Charlie. Right back into that same slot. You'll hear a click when the node is successfully seated in the slot. We're going to install the external drives you previously removed. It's not critical that they go in the same slot, but it's probably a good idea. Okay. Be sure to install the external SSD in the lower slot. If you put it in the upper slot, it's not going to be found. The software on the nodes instructs the nodes to ignore that slot. Connect the network cables to the same interfaces. Make sure that they get link. The network card has standby power, so it has enough power to get link. Then power the button node up with the front power button. Okay. So the node boots, and the system is going to recognize the replacement node as an unconfigured new node. Why is that? Because it's got a different MAC address, so it's not going to be found. It's got a different hardware serial number. It's got different system files, all that kind of stuff. because all its identity is on the internal NVMe drive, which we also replaced. But all those external drives still contain PanFS component data. So again, it has an inconsistent internal file system because the internal NVMe goes with that. And it no longer stores the complementary data components. The node is going to figure out something's wrong, and it's going to set a property of plus failed for its internal file system. It's not going to come online. The president's going to put the node into not responding, not activated. A node that is in plus failed cannot come online. Not activated means I'm not going to put it into the blade set because it's plus failed. So the corrective action here is just like before. We're going to reinitialize the node. It's going to lay down a new file system. It's going to be happy with that. It's going to clear this plus failed, and it's going to come up. Now, the system files may have different PanFS version that is installed on your realm. If that's the case, then the M console is going to automatically upgrade or downgrade the node. That may take a few minutes. The node is going to reboot. It's going to take the same time as it did for the upgrade of the realm, not 20 minutes because it's only this one node, but it'll take several minutes. Then after the reinitialization and any PanFS offers an upgrade, the node now should come online. This time, if you're using IPMI, whatever IPMI address the node had, it doesn't have it anymore. That was on the BMC chip, which is on the node. So you're going to configure IPMI. We're not going to go over that in this course. Occasionally, and very rarely on the newer versions, we give customers a custom IOPath v4 JSON file so that the OSDs run with a little bit different configuration. If that's the case, that file is now gone. We're going to copy that into place. And this article I actually just created that this time. We usually just give the customers the instructions individually. But basically, we're just going to copy it into place. Back up the original, copy this into place. The IOPath v4 process is going to read it when it starts. There are basically at this point 2 customers that need a larger metadata loop 0 device than is standard. That is where the internal hard drive metadata is. We store that on a loop device on the NVMe drive because it's much faster, makes the performance of the hard drives faster. The default is 200 gigs. These customers have a lot of component data. They need a larger loop device, so they need to run some commands to resize it. And that's in this article right here. Most people do not need to do these things. Actually, this needed to have been done if we replaced the drive as well. I need to change that. If we just replaced a drive, we do not, and we had a custom IOPath v4 JSON, we do not need to replace it. That's on the system files. It's still good. Go. All right, so now everything's still good. If you have a secure drive support contract, we're going to open the failed node chassis. We're going to remove and destroy the internal NVDIME, NVM, and the NVDIM. That means because these hold data, and you're going to return the failed node to Panasas. Mike, you have one of these things. You're not going to give us any drives back whatsoever. Most customers don't have this. They're perfectly happy to give these back. That really doesn't allow us to read any kind of data or anybody to read any data, but people with very secure data don't want to give them back anyway. Could put the node chassis in the box the replacement came with. There's a prepaid FedEx return bill. If you can't find it, we'll give you another one. And these knowledge base articles here give the command line version of the steps that we've run. Okay, let's stop and ask if there are any questions about replacing either a storage node drive or the storage node itself.
None for me.
Okay. Directors. The system automatically removes a failed or drained OSD from its blade sets. It also automatically removes the record of the OSD when the OSD was replaced. That is not true for directors because they are not in blade sets and we just really don't want to be getting rid of their records. I mean, because we don't have a system for knowing when the system is not used. So if we're going to replace them, we have to do a number of things. And we did 2 of those things in our example. So first thing we're going to do is we're going to gracefully move the relevant volume services. We're going to disable IP aliases, which we're not covering in this course. If NFS is using an IP alias, you want that to move. The only way to do that is to disable aliases on the node, and it will fail over. Okay. First thing we're going to do, if the node is a rep set member, we're going to remove it from the rep set. You saw us do that in the GUI. We never added that back. We'll make sure we do that in the lab. Again, if the node is the realm president, this causes an outage of about 30 seconds. We discussed this on the second day. Otherwise, the step should not cause an outage. You saw that it caused no outage when we removed 1.2 from the rep set. If for some reason you had 4 directors and the director node will not be replaced for some time, you probably should add that other director from the rep set. If the node is going to be replaced right now or the next day, it's fine to leave it with just 2 for rep set members for a very short time. If it is the active or primary director for any volume services, we're going to move these to another director. And there was a topic on this. We're not going to bother with moving the backup assignments because that's just too much to fix once the replacement is there. It's fine to leave those volume services without a backup assignment for a short time. Okay. It's going to be a long time. We're going to go ahead and manually assign backups. And we would do that by selecting the volume service and just selecting the backup and say move backup. That's a little bit more advanced than in this course. We very rarely would do that. And if it was so, Panasas technical support would tell you how to do it. If we're using NFS aliases, we're going to disable aliases for the director. So the president will fail over the alias to another director. So NFS will continue to the director. And again, we're not talking about NFS in this course. Halt the node. This is assuming that it's even responsive. Now we're going to remove the node's record from the realm database. You see this clear record of node? Otherwise, if you just replace the director, the system's not going to know what happened to the other director. There's not like an OSD where it just figures that if you replaced it, we can kick the other record out. It's going to show up as a ghost node. So we clear this record of it. This page will reboot and return an error saying this node doesn't even exist, and that's fine. You do the halt first because once you clear the record, there will be no halt command. You can always go to the director and just power it down, but the halt is better. Now, here we are, and we're diverging between the ASD 100 and the ASD 200. Now we're talking about the Bravo ASD 100 director nodes. What happened if we need to replace the SSD? This is kind of rare, actually. So we're going to run the preliminary steps to replace any director. Then you're going to go and remove the front cover. You're going to find the director. And as we said earlier, there are 16 drive bays in the front of this chassis. 2 of them we don't even have sleds in. The other 2, half of them have drives, half of them don't. The ones that have drives have this little D sticker on it, but you can just know it's the outside corner. And the node number, we do not have the ability to flash the drives, but you're sitting there looking right at the node number, and there's only 1 drive. So you're going to press it in, pull it out. You're going to replace the entire thing. The replacement comes in this tray sled. You're just going to stick it in until it clicks. Then you're going to boot up the node. Power up the node. IPMI was configured. It should be configured with the same IPMI address, and it's going to get the same IP address because, again, it's got the same MAC. Reinitialize the node. Actually, this is not inconsistent the way that a storage node is. It should just work and figure out that we've got a new system for an old body, but we've had problems with it, so we're just going to reinitialize it. Using the commands shown early in this topic, is the very same commands. All right, so then the node is logically new. It's going to draw the realm. We're going to add the director back to the rep set if it was before. We're going to balance the volume services if they need to be balanced. Failed drive does not need to be returned to Panasas. Destroy it or whatever. Please fill out a certificate of destruction. We have not been requesting those, but it's still in our documentation. Okay. Now let's say we're not replacing the SSD. We are instead replacing the node itself. We're going to remove, you don't have to replace the OSD. These are not connected. They're both connected to the shelf midplane. We're going to remove the network cable. There's an IPMI cable that's going to be there. We're going to push this latch lever to the right, this way, to release the node. And we're going to grab this nice sturdy handle here and we're going to pull it out. We're going to install the replacement. We're going to hear a click when it's successfully in the slot. We're going to connect the cables, verify that it gets linked because it's got standby power. I'm going to go around to the front and power on the node with the front power button. It's not going to have networking because we halted the node and various other things. We found through experience it's just best to connect the console. If you're going to use the 4x10 breakout cable, there's nothing to be done. If you're using the 2x40 mode, where you're connecting 240 gig things, that NIC comes in 4x10 mode, you're not going to have any connectivity. So you need to SH into that. We're going to go into service mode. We're going to run this script to change the NIC into 2x40 mode. And that's in this knowledge base article. Configure IPMI if desired, because it's got a brand new BMC chip, and the command to do that is in this article. We're going to boot it up. We're going to reinitialize the command locally using the commands described previously. And it should join the realm and come online. It's got these same system files as before. Again, if you didn't reinitialize, the systems would say, oh, this director has a new body. But it's easier to reinitialize than it is to do anything else. The MAC address is different. It will receive a different IP address than it had before. If this is a rep set member and we want it to have the same IP address, there is a knowledge base article that will tell us that we need to SSH into the whatever rep set member is running the DHCP service, we're going to run the command service mode, go into service mode. We're going to run the commands netconfig, IP ranges, IP change. It's going to prompt us for the IP that the node has now. It's going to prompt us for the IP that it's supposed to have. It's going to restart its service for some reason that I don't quite understand. It's going to reboot the node, and when the node comes up, it should have the IP that you wanted to. Then you can add the node to the rep set, and you can balance the volume services. That's the 100. The 200 is all one piece because its system files are on the M2 NVMe SSD on the motherboard. There is no this or that. You're going to power down the node, remove the network cable, pull out the node, put the new node in, put the network cable back in, power it up. Just like you used to do with the old director blades. One piece. Pick it out, put it in, power it up. You do not need to reinitialize it. It is not inconsistent. The whole thing was replaced. The whole thing was consistently configured at the factory. Here's the back of the node. This is similar to the ASU nodes, but the nodes are in the back. We've got a latch layer lever. It's on the other side. So you're going to push this down. We've got a floppy pull tab. We're going to pull the node out from the back. I'm going to connect the network cables, power on, verify that they have link. There's no configuration in the networking that's required on an ASD 200. The NIC only has one mode, assuming that you're using LACP. Power on the node with the front power button. The node should boot, get an IP address, join the realm. Don't have to reinitialize it. Maybe it needs to off version upgrade or downgrade. If the version is not the same as the realm, the node should come online. Configure IPMI if we want to do that. And if the system is not using the default LACP, we're going to configure the node's networking. I'm actually going to take that out because that's so rare, it's just confusing. Again, we're going to add the node to the rep set if it was supposed to be, and balance the volume services. If you have a secure drive support contract, you're going to open up the failed node's chassis. You're going to remove and destroy the internal NVMe drive in the NVDIMM and fall out a certificate of destruction. For the 100, you would have opened it up and removed the NVDIMM. I need to add that. The ASD 100 does not have an NVMe drive, so you don't have to worry about that. Again, we're going to return the failed director node chassis to Panasas. For any of these directors, if it's supposed to be added to the rep set and does not, oh, here, I put it in here. We're going to change its IP address with this command, and you're going to put in the new one. It's going to reboot. You're going to confirm when it comes online that it has the right IP address. And the reason we're doing this before we add it to the rep set, you cannot change a rep set member's IP this way. The only way to change a rep set member's IP address was with that netconfig edit script that we did, which reboots the whole realm. We don't want to do that, so we want to change the IP address before we add this to the rep set. Now we're going to add it to the rep set using the same procedure that we did when we were doing our rep set type. It was not a member of the rep set or another director was already added. This step is not necessary, but just take a look at the rep set page to make sure you've got a fully redundant rep set before we decide that it's not needed. Now we're going to rebalance the volume service. We're going to go to this page. The replacement director will not have any primary volume service. The president just doesn't reassign these. It will just automatically reassign the backups, assuming there's no reconstruction going on. So we're going to move one or more primary volume services to balance the PanFS metadata load among the realm's directors. You want each director to have probably just one primary volume service. There are some exceptions to that, but generally, as you saw when we did this in our demonstration, we didn't move the same one that we had moved off, but we moved one so that each director had only one. The president probably will assign the backup services, give it a little time to sort it out. It may not be exactly the way you want it. You can move the backup services if you want. And we'll take a look at how to do that once we get back to the realm. Have a secure drive, support contract. If faulty part is an ASD 100 external SSD, just throw it away. Oh, here, I do put it here. If the faulty part is the ASD node 200, open the drive chassis, remove and destroy the NVDIMM. Faulty part is ASD 200, remove the node chassis, remove and destroy the internal NVMe drive and the NVMe. And there are knowledge base articles. We probably need an extra article on how to open up and destroy these drives. All right, what about the power supplies? Panasas enclosure power supply may be hot swapped if the other enclosure power supply or supplies have a green LED. If they're in some kind of warning state but still functioning, you don't want to pull the only working power supply. I've never seen this with regard to Ultra. I have seen it with some of the older stuff. So it's just a good idea before you pull a power supply, look at the other power supply, make sure that it's good. Install the replacement power supply. You'll hear a click when it's seated. Attach the power cord. This is fully hot swappable. Verify that it's green and verify the replacement power supply is recognized in the GUI. You're going to go to the enclosure detail and see that it sees all the power supply. Here's some pictures. Here on the ASU 100, here's one of the power supplies. The latch lever you push down, you pull it out. The ASD 100, it's got this Intel size latch layer. You push it to the right, and there's a handle right there that you're going to pull. ASD 200 is similar to the ASU 100, only it's on its side. So you're going to pull the latch layer that way, pull it out. Very, very simple. Network cable. These can be hot swapped. You want to swap them one at a time. Now, if it's an ASU 100 and it's in the 4x10 mode, when you replace the cable, it's going to take the node's connectivity out. But usually, if you're replacing the cable, there was something wrong with it anyway, and it may already have no connectivity. So, if you're doing it for a redundant ASU or ASD 25 gig interface, or if you have 2x40s, this should not disrupt the connectivity. I will say with a caveat, you never know with networking. Yeah. Replacing the ASD 100, it will interrupt the node's connectivity. Faulty cables are expendable, just throw them away. If we're not sure that it's faulty, you can stick it somewhere to be used as a spare, mark it as a suspect spare. We don't care what you do with it. Replacing an enclosure. This is rare, but sometimes it happens. If we replace multiple things and things just keep failing and we don't know why, sometimes we say, maybe it's the enclosure, we'll send you a new one. This requires an outage. This basically is the time that it takes you to physically remove the nodes, unrack the old enclosure, rack the new one, put in the new enclosure, plus about 10 minutes. We take the realm offline. There is a button to do that in the front of the hardware page. We're going to power down and remove the nodes and the power supplies from the enclosures. Probably do not want to remove the drives because we do not want these nodes to be healthy. These nodes are going to be very heavy with the drives, but just get a buddy to help you with them. Go. Label and remove each network cable or power cord, label everything, pull them out, unrack the old enclosure, rack the new enclosure, install everything exactly the way it was, power on each node with the front power button or IPMI. When at least one node reports its enclosure serial number to the realm president will create a record for the new enclosure, the realm database. It will not be the right name. It will be the next name. If you are replacing, say, the enclosure ASD-1, the new, or let's say ASU-4, and you have 8 enclosures, the new enclosure will be named ASU-9. And you will actually see two different enclosures for a while because until all the nodes report to the president that they are in the new enclosure, the president will then figure out that the old enclosure does not exist and it will disappear from the realm database. Then you power things up, make sure the nodes are online, you bring the realm online, and you rename the enclosure to the name the enclosure had. We saw how to do that in the GUI. It's just a label, so that's quite easy. Okay. Review. Is replacing active store hardware before Panasas technical support is created an RMA for it the best practice?
Yes.
No.
No. You don't want to just replace stuff. You want to say, I need a new part. We want to verify that you do need a new part. Even if you are, even if it is correct, we still want to query something about the part while it is still part of the realm. Okay. We can work with you if you've already replaced it, but it's a whole lot easier if we get the paperwork straight before we start this. In what 3 states, OSD states, may the node be safely replaced?
Failed.
Yes, failed.
Inactivated.
Not activated, yes. And one more.
Drain.
Drain, yes. Y'all are killing it. That's good. Just the fact that a GUI shows a node offline mean that the node may be safely replaced.
Why not?
No. Offline can mean just about anything. You need to go into the node's detail pages and see what its state actually is. Offline is kind of a flag. Okay. If it's in offline reconstruction, no, can't be replaced. Offline failed, yes, it can be. Can a Charlie or Echo storage node external drives be individually replaced?
Yes.
Yes, they can, yes. If the answer to this is yes, which we said it was, what action must be taken on the storage node after a drive has been replaced?
Has to be reactivated.
No, there's another word. File system is inconsistent. It's going to be, it's going to set itself to plus failed. So what do we have to do? Fortunately, you're not really familiar with this. You never want to reinitialize something on your own until we tell you it's safe to do this. We're going to reinitialize it to make it a logically new node so it can lay down a nice clean file system. Can a Panasas node be reinitialized from the GUI in most cases?
Yes.
No. At our request, at the request of technical support, this button has been removed from the GUI. Only if the node has no data can it be reinitialized. And apparently it's too tempting. You have to run a PanFS command. If a failed node reboots, it's going to come up and says needs reinitialization. Kind of makes it sound like you should reinitialize it, doesn't it? It's not. It's just saying it's not going to be allowed back in the realm unless it's reinitialized. That doesn't mean it's a good idea. You do not want to put something with a hardware problem back into the realm. So we figured that somebody that didn't know that might be tempted to do it in the GUI, but they may not know the command to do it in PanFS. So it's gone from the GUI. The command to reinitialize the whole realm is also gone from the GUI. It was in the GUI for years and years, but that's just too dangerous. Technical support tries to remove things that might get you into trouble. Are there cases where configuration should be updated after an ASU node is reinitialized? Kind of a vague question, but
Yes.
yeah. If technical support is giving you something custom, and if that's the case, we've told you exactly what you need to do, then you need to do it after it's reinitialized. Very simple. Can existing external drives be reinstalled in a Charlie or Echo storage node if the node chassis is replaced?
Yeah.
Yeah. The answer to this is yes. What action must be taken on the storage node after the node chassis has been replaced? That should be after the drives have been placed or whatever.
Install drive. I
Something
think.
else after that.
Network.
After that, same thing. It's inconsistent. We have to reinitialize it.
Initialize it.
Yeah. The ASD 200 storage blades, director blades, ASD 200 are the only nodes that do not have to be reinitialized after replacement. It's because they're all one piece. The new Echo directors will also be one piece. So the new Edge directors. Kind of like my brain thinks that every word that starts with an E is the same. The new Edge directors will be all one piece. The Edge storage nodes, again, will have external drives. Does a Panasas node retain its IPMI configuration if an external drive is replaced?
Yeah.
Yes, it does. Does a Panasas node retain its IPMI configuration if the node chassis is replaced?
No.
It does
No.
not. Have to reconfigure it again. The IPMI configuration lives on the BMC chip on the motherboard. What system action should be taken before replacing a Panasas director? There's two of them. Well, three really, but two very important ones.
Remove from the rep set.
Remove from the rep set, yes, and? Is there anything else on that node that you don't want just failing over?
Is it the backup?
The volume service, yes.
Right.
if there are primary volume service, if this director is the primary volume for any volume service, you want to move those. Don't worry about it if it's the backup. By the way, I've decided that sometimes people do want to assign a backup. It's just a matter of taste. What system actions should be taken after replacing a Panasas director?
Has to be added to the rep set?
Add it back to the rep set, yes, and
It will automatically assign as a backup for a.
it will assign it as a backup, but will not automatically assign the primaries to it.
Okay.
You want to balance the volume services because probably at least one, maybe two directors have too many. You want every director pulling its weight and participating in the volume metadata. So we want to move at least one of the volume services to the director, probably just one. Maybe you move two off. The root directory can usually stay wherever it is, but what action must be taken on a replacement Bravo ASD director node if two 40 gig cables will be attached?
You have to reconfigure the NIC, right?
Yes, perfectly. You have to reconfigure the NIC. By default, it is configured. For the other way, you will not have any connectivity until you do that. Must a Panasas node be powered down to replace an enclosure power supply?
No.
No. Perfectly hot swappable. It's not even part of the node, but just kind of emphasizing that. Must a Panasas node be powered down to replace a node network cable?
No.
Must a Panasas, that's correct. Must a Panasas node be powered down to replace its enclosure?
Yes.
Yes, absolutely. It's got to be unwrapped. Okay. Questions about this?
Nope.
All right. We have knowledge base articles on all this. I think I'm going to make a link in the knowledge base article to these slides. And these slides are available on my.panasas. And we will talk about how to access them in our next topic or the next one down the line, but today. But it would be very nice if we just had a nice handy dandy link on the knowledge base articles. We usually attach the knowledge base articles about how to replace the thing to the service request. So it'll be right there at your fingertips.
Yes, please. It's needed because we don't have access to my.panasas. So at
Mhm.
least access the knowledge base, please.
Yeah, well, you have to be able to access my.panasas to get to the knowledge base articles, but you will have a copy of the slides.
Okay. Thank you.
Hopefully, at some point, you will have access to my.panasas.
Yep, I used to have it, but it's gone. So
Yep. Yeah.
let's see. Hopefully soon we will
Yes.
have it back.
All right.